Do you hear about that fucking object that's hurtling towards Earth at like 130,000 miles an hour?
No, that might solve all our problems.
Some intergalactic object.
What came blazing out of the darkness wasn't supposed to arrive this fast. A comet-like object from beyond our solar system sprang into view, racing through space at unimaginable speed, changing color and behavior as it closed in. It defied every model, every expectation. On the latest Joe Rogan podcast, the question being raised isn't whether it's natural, but what it could be. Because when something accelerates out of nowhere, there are always two possibilities: unknown nature or unknown design. The sudden acceleration. The data first appeared as a small inconsistency in orbital tracking, a fraction of a decimal point separating prediction from observation. Astronomers at multiple observatories noticed it within hours. The interstellar object known as 3I Atlas, once thought to be following a predictable inbound arc, had suddenly deviated. Its velocity had increased, not gradually but sharply, as if something had given it a push from behind. Acceleration in space isn't unheard of. Comets often speed up as sunlight heats their icy surfaces, releasing jets of gas that act like natural thrusters. But 3I Atlas wasn't close enough to the sun for that process to explain its sudden burst of motion. The readings showed a leap in speed of nearly 20% within a single observation window, without the expected plume of debris or outgassing signature. It was moving faster, cleaner, and more precisely than any natural object in recorded history. Astrophysicists initially attributed the anomaly to instrument error, yet when the European Southern Observatory, the James Webb Telescope, and multiple ground arrays confirmed identical readings, the explanation collapsed. The acceleration wasn't an illusion, it was real. The object's trajectory had changed, flattening slightly, as though it had adjusted course intentionally. For researchers accustomed to the slow ballet of celestial motion, this behavior was unnerving. The acceleration pattern matched neither solar gravity nor sublimation thrust. It was uniform across multiple axes, the kind of smooth, controlled motion typically reserved for engineered propulsion. News of the anomaly spread quickly. Within hours, science communicators, YouTube theorists, and podcast hosts were dissecting the data. The words non-gravitational acceleration appeared in official documents, the same phrase once used for Oumuamua, the first interstellar object to defy conventional physics. 3I Atlas wasn't just moving, it was choosing to move, and that single observation marked the beginning of one of the most unsettling debates in modern astronomy: the debate over natural versus artificial. The acceleration of 3I Atlas ignited a scientific argument that spread far beyond observatories and academic journals. On one side were the traditionalists, astrophysicists convinced that every anomaly could be explained through physics, chemistry, or coincidence. On the other were the skeptics of skepticism, scientists like Harvard's Avi Loeb, who saw in this motion something deliberate, a controlled maneuver impossible to reconcile with the natural behavior of a comet. The official reports emphasized restraint. They described the object's sudden velocity increase as non-gravitational acceleration, likely associated with volatile activity. Yet no trace of sublimated gas or dust tails appeared in any of the infrared imagery. Its surface temperature remained low, far below the threshold for water, carbon dioxide, or even ammonia ice to vaporize. The object was cold, inert, and somehow still accelerating. This contradiction became the focal point of late-night science podcasts and long-form discussions. The Joe Rogan Experience dedicated an entire segment to the phenomenon, highlighting how 3I Atlas's behavior mirrored that of Oumuamua, the cigar-shaped object that passed through the solar system years earlier. In both cases, the same unexplained energy signature appeared: movement without propulsion, acceleration without fuel, direction without core. Conservative astronomers called it radiation pressure, sunlight gently nudging an extremely light, thin structure. Loeb countered that such a model required 3I Atlas to be almost weightless, more like a sheet than a rock, an interstellar sail designed to harvest starlight. The idea seemed absurd until the data fit perfectly. As the debate grew, something deeper began to unsettle the scientific community. The pattern of acceleration wasn't random. It followed discrete interval, increasing and then stabilizing in repeating 9-hour phases. The object behaved less like a drifting relic and more like a machine responding to commands. To the public, it became another curiosity in a universe of wonders. To astronomers, it was a quiet, existential crisis, proof that the line between natural and artificial had blurred, and that perhaps the cosmos was no longer silent. The pattern behind the motion. When astronomers overlaid weeks of data, the behavior of 3I Atlas revealed a structure far too organized to be random. The acceleration was not a single burst, followed by steady drift. It repeated in interval. Every 9 hours, the object's velocity increased fractionally, plateaued, then reset. Each pulse of movement followed a symmetrical curve, identical in duration and amplitude. Natural objects never move this way. Solar radiation pressure acts continuously, not rhythmically. Outgassing, the process by which frozen volatiles sublimate and push a comet forward, produces chaotic spurts, inconsistent in both direction and force. But 3I Atlas moved as though driven by an internal timer, its trajectory altering with the precision of a guidance system. The data spread through research institutions quietly at first. Modeling teams from NASA's Jet Propulsion Laboratory and the European Space Agency began simulating the acceleration in software used to analyze spacecraft propulsion. When fed into those frameworks, the pattern matched nearly perfectly with low-frequency plasma discharge, a type of propulsion system capable of generating tiny but continuous thrust over long durations. Further analysis showed another oddity. The orientation of the object's rotation shifted ever so slightly during each acceleration pulse, correcting itself with uncanny precision. The movement resembled course stabilization, the kind of automatic adjustment used in spacecraft to maintain trajectory alignment. Astrophysicists, reluctant to embrace speculative conclusions, called the phenomenon dynamic equilibrium adjustment. Others saw it as a form of intentional control, a sign that the object was responding to gravitational influences in real time. Even the raw optical data carried subtle anomalies. The brightness of 3I Atlas increased slightly before every acceleration phase, then dimmed immediately afterward, as though heat was being generated and then radiated away. To some, it suggested chemical processes or magnetic induction. To others, it was evidence of an internal system managing its own energy. By late autumn, observatories worldwide had confirmed the pattern. Whatever 3I Atlas was, it was not a passive traveler. Its acceleration and rotation had become synchronized in a way that implied structure, not chaos, but design. The spectral mystery. While the acceleration of 3I Atlas drew the world's attention, it was the object's spectral signature that caused genuine alarm among astronomers. Using the James Webb Space Telescope and several ground-based infrared arrays, scientists began scanning its surface composition, expecting the standard cometary elements: frozen water, carbon monoxide, and traces of silicate dust. What they found instead did not fit any known profile. The first anomaly was metallic reflectivity. Across multiple wavelengths, 3I Atlas exhibited a mirror-like return pattern, suggesting that large portions of its surface were composed of refined metals or high-albedo composites. That level of uniform reflectance is impossible for a natural comet, whose surface should be darkened by organic carbon and cosmic dust. The brightness remained stable over time, indicating no tumbling debris or rotating irregularities, only a smooth, consistent texture. Next came the thermal paradox. Despite its proximity to sunlight, the object's temperature did not rise proportionally. Instead, its heat output fluctuated independently of its solar exposure, rising sharply during each acceleration pulse and cooling just as quickly afterward. The infrared charts displayed spikes resembling energy discharges, controlled bursts of heat emission unlinked to sunlight or sublimation. Even stranger were the traces of nickel vapor and carbon dioxide surrounding the object. Those elements do not coexist naturally at the observed ratios. Nickel requires thousands of degrees to vaporize, while CO2 sublimates at extremely low temperatures. The combination implied alternating cycles of intense heat and near cryogenic cold, impossible for a static body. When Webb's spectroscopy team compared the readings to known propulsion exhaust signatures, they noticed disturbing similarities. Nickel vapors are a byproduct of plasma thruster alloys used in experimental spacecraft engines. The faint CO2 presence could indicate a cooling or exhaust system. The data pointed toward technology, or at least something behaving as if it were technological. No official statement acknowledged this interpretation, but internal documents began classifying the object's spectral data as non-standard. Observatories tightened their data channels. Raw images were removed from public archives without explanation. Whatever was on or within 3E Atlas, it wasn't reacting passively to its environment. It was emitting, stabilizing, and possibly managing its own temperature. And as it moved farther into the inner solar system, that control seemed to be intensifying. The reversal near Mars. By the time 3I Atlas crossed the orbital path of Mars, something happened that defied every simulation. For months, it had been steadily accelerating toward the inner solar system. But on October 3rd, the data from both NASA's JPL and ESA's Gaia system registered an abrupt velocity reversal. The object's forward speed decreased, then plateaued, as if it had applied brakes against gravity itself. Natural deceleration doesn't occur this way. When comets lose momentum, it happens gradually through the drag of sublimating gas or gravitational slingshot effects near large bodies. Yet 3I Atlas slowed in free space, far from any planetary mass capable of altering its trajectory. The deceleration occurred over just 12 hours, a maneuver so deliberate in curve and precision that it appeared engineered. Orbital reconstructions revealed a subtle shift. The comet's vector turned slightly off-plane, avoiding Mars's gravity well by a margin of only 0.03 degrees. Such precision would require real-time navigation. At its velocity, even a deviation of 1/10 that angle could have resulted in a catastrophic gravitational capture. Instead, 3I Atlas executed what flight engineers would call a course correction, a movement indistinguishable from active control. The change was accompanied by a transient rise in thermal emission. Instruments recorded a temperature surge of nearly 4,000 Kelvin across a localized point on the object's leading surface. No visible flare, no debris cloud, no disintegration, just a clean energy spike and immediate stabilization. In the following days, 3I Atlas resumed acceleration, now on a slightly modified trajectory, one that placed it on a near-collision course with the orbital plane of Jupiter before veering outward again. The maneuver could not be explained by gravitational mechanics alone. It appeared calculated, as if the object were testing the limits of the solar system's pull, probing, adjusting, and learning. Planetary scientists attempted to classify the event as a sublimation-driven jet, but no material outflow was detected. The Mars Reconnaissance Orbiter, which scanned the region days later, reported faint electromagnetic interference along the path 3I Atlas had taken, residual energy still dispersing through space. The shockwave of theories. The Mars maneuver shattered the already fragile consensus around 3I Atlas. Within days of the deceleration event, scientific institutions, space agencies, and private research foundations were divided across ideological lines. Each faction built its own explanation, none of them entirely comfortable. The mainstream position held that sublimation or outgassing was responsible, despite the absence of any vapor trails. According to this model, internal pressures might have built up beneath the comet's surface, venting intermittently through micro-fractures to create jet-like thrust. But this theory quickly failed under quantitative scrutiny. The energy output required for the observed change in velocity was thousands of times greater than any natural venting could produce. No amount of trapped gas could have generated that level of force without obliterating the object completely. The alternative theories spread faster. Some proposed that 3I Atlas was not a comet at all, but an ancient probe, a remnant of interstellar technology built by a long-extinct civilization. The pattern of acceleration and controlled deceleration matched artificial thrust signatures seen in ion drive simulation. Others suggested the object might be a fragment of a Dyson-type construct, a self-regulating shard of machinery powered by absorbed starlight. The idea wasn't new. Avi Loeb's earlier work on Oumuamua had already introduced the possibility that interstellar objects could be engineered sails, relics drifting between stars. His arguments, once dismissed as speculative, now resurfaced with renewed force. Observatories reanalyzed archived data from Oumuamua and 2 Chuy Borisov, comparing their motion patterns to 3 I Atlas. The similarities were undeniable. Each had shown moments of inexplicable thrust, but 3 I Atlas's movements were far more deliberate. Parallel to the academic debate, public fascination exploded. Space-focused podcasts and forums filled with speculation, merging physics with myth. People began linking 3 I Atlas to ancient texts describing celestial messengers, planetary cycles, and cataclysmic returns. The name Atlas itself gained a symbolic weight, the figure that holds the heavens. Yet beneath the sensationalism, one uncomfortable reality persisted. Every explanation required admitting that our understanding of interstellar motion was incomplete. The acceleration, reversal, and realignment of 3 I Atlas weren't errors in data or chance anomalies. They represented intentional dynamics operating on an astronomical scale. In every model, every simulation, one fact remained constant. No natural mechanism could account for the precision. Something was driving it, and it was obeying rules humanity had yet to learn. The Webb Telescope anomaly. When the James Webb Space Telescope turned its golden mirrors toward 3 I Atlas, the data it captured reshaped the entire discussion once again. Webb's infrared instruments were capable of detecting heat signatures and surface compositions with unprecedented precision, and what it saw was neither random rock nor frozen debris. It was structured. The first images, filtered through mid-infrared wavelength analysis, revealed alternating heat bands across the object's surface, concentric patterns, equidistant and symmetrical, rotating in perfect sync with the object's 9-hour periodic acceleration. Each thermal band radiated at a different intensity, as though specific regions were activating and deactivating in cycle. For a natural body, such uniform distribution was impossible. Further analysis of the spectral data added to the mystery. Instead of the broad, uneven peaks typical of natural minerals, the emissions formed sharp, discrete lines, signatures usually associated with refined alloys or crystalline structures. The reflectance curve matched no known asteroid, comet, or meteorite catalogued by NASA or ESA. The readings appeared engineered, as if designed to channel energy across the object's surface. During the 36th hour of observation, Webb's sensors detected a flash, a brief surge in infrared radiation originating from the object's equatorial region. The spike lasted only 4 seconds, but was intense enough to saturate the detectors, forcing an automatic cooldown. In that moment, the object's apparent brightness increased tenfold, only to return to its baseline almost instantly. When analysts recalculated its velocity afterward, they found a minor increase, a fresh burst of acceleration consistent with propulsion. The energy pattern was unlike any natural phenomenon recorded in astrophysics. The object seemed to pulse energy in controlled interval, storing and releasing it with precision. Some hypothesized this might be a reaction to solar wind, a way to absorb and redirect radiation pressure. Others, less constrained by orthodoxy, described it as activation, a self-sustaining mechanism awakening deeper systems inside the structure. The Webb telescope's results were quietly removed from public access within days. The official summary listed instrumental anomalies under review, but archived data stored by independent research networks confirmed the event. Something had happened during those brief seconds, something measurable, reproducible, and deliberate. The radio silence that followed. After the James Webb Telescope recorded its last infrared pulse from 3 II Atlas, the global scientific community entered what could only be described as an observational panic. Data streams that had been stable for months began failing across all major observatories. The anomaly wasn't isolated, it was systemic. One by one, instruments that had been tracking the interstellar object went dark. The loss began with low-frequency radio telescopes. At first, the signal degradation seemed like standard interference, but within hours, every radio observatory on Earth reported the same problem: total signal absence within the coordinates of 3 I Atlas. The region became a blank zone in the electromagnetic spectrum. Not noise, not distortion, but the complete removal of measurable radiation. Even background cosmic hiss vanished. It was as if a patch of the universe had been erased. Infrared sensors followed next. The object, once glowing faintly from internal heat fluctuations, cooled rapidly, or more accurately, it masked its own emission. Its albedo collapsed by nearly 80%, suggesting a sudden change in surface properties. What once reflected light now absorbed it completely. The comet's radiant profile flattened to black. Magnetometers aboard Mars orbiters and several deep space probes detected faint pulses at 9-hour interval, identical to its previous acceleration rhythm. These pulses were magnetic rather than optical, invisible yet perfectly periodic. It was the only trace left, a heartbeat in the void. Attempts to restore observation failed. The signal blackout moved with the object, growing larger, forming a tail of electromagnetic silence trailing millions of kilometers behind it. No radar ping returned, no telescope image resolved. The silence was total and moving. Within NASA and ESA, internal documents began referring to the phenomenon as the Atlas Null Zone, a self-generated cloaking field beyond theoretical capability. The public updates called it temporary signal disruption, but the unredacted logs described something unprecedented. Object entered self-occluded state. All energy emissions below detectable threshold. Magnetic resonance remains. Synchronized, sustained, intentional. For the first time since its discovery, 3 I Atlas had not only accelerated, it had vanished from every instrument designed to perceive it. And yet, every 9 hours, the planet's magnetosphere faintly pulsed in reply, as though something unseen still echoed across the system. In the following weeks, the blackout expanded beyond the object's trajectory. Interference began affecting outer planetary probes, disrupting long-range communication arrays, even flickering through certain deep space frequency bands used for interstellar mapping. The silence was spreading, steady, organized, deliberate. Then, on a clear midnight in early November, the faint pulse stopped. No residual magnetism, no radiation, no trace. The corridor of silence closed behind it, leaving nothing but background noise. The official record now lists 3 I Atlas as unrecoverable, presumed outbound. But for those who studied its last days, the phrasing feels incomplete, because things that drift naturally fade. They do not shut themselves off. If acceleration was its first signal, then silence was its last. And somewhere beyond Jupiter's orbit, an object once visible to every telescope on Earth had done something no comet or machine ever had. It chose to disappear. Thanks for watching another episode. While you are still here, make sure to click the video on your screen for more quality content.